Hey guys, this is Mr. Grice for Algebra 2 Unit 3.4 Notes. Today we're talking about graphing absolute value functions. Our learning target today is to be able to graph absolute value functions and their vertex, max, min, and, that's right, transformations. So let's go ahead and get started. Now we know that absolute value is a distance a number is from 0. So what we're going to do is solve the first part. So the parent function is kind of like the basic function. There's no bells and whistles. There's nothing before, nothing after, just the absolute value of x. So the absolute value of a -2. What is the absolute value of -2? So if we were to plug in -2 here, what would our answer be? Yeah, the absolute value of -2 is 2. So if I wanted to graph it, I would go -2, 2. The absolute value of a -1 is 1. The absolute value of 0 is 0. Sorry, I'm doing this kind of fast because you guys should know this. Now, the absolute value of 1 is 1. The absolute value of 2 is 2. And what do you notice about this graph? What does it make? Yeah, it makes a V. Okay, so what I'm going to do real quick is graph it. Here I am searching through my desk, trying to find my cool ruler. And there we go. There is our parent function. Now, one thing I want you to notice is the slope. From the right, we're going up 1 over 1, up 1 over 1. And then on the left, we go up 1 over 1, up 1 over 1. So our slope, which is we're going to talk about in a second, our a is kind of 1 over 1. Now, there's also a way to graph it on your calculator. We go to y equals, there's a way to find absolute value, and so there it is. Now, what I want you to notice is our next one. The first thing to notice is, yes, there is a negative out front. Okay, I'm going to go to math, number, hit absolute value. In the inside, we have x plus 1. And then on the outside, excuse me, on the outside we have plus 2. So when I graph that one, you guys already see it on yours, but that's what it looks like. It's different. What's going on? So let's identify some of the things that's going on. Now, the first thing that I notice is that it's reflected, okay? And what I mean by reflected, it's over the x-axis. Our first graph was going up, but this graph is opening down. That's reflected. And the reason why it's reflected, it's because of the minus sign. Now, I also notice that there's a horizontal shift. Okay, now the horizontal shift, see, our blue one is the parent and it said 0, 0, but I went left 1. So that is our horizontal shift. Let me write that down. There's a horizontal shift, and we went left 1. Now, the reason why there is a horizontal shift and we went left 1 is because of that plus 1 out there. And then the last thing that happened has to do with this 2. Okay? And if you notice, before we were at 0, 0, but now it's up 2. So that means that there was a vertical shift and we went up 2. So we went from here up to there. Okay, so some general information. This is our basic function that we see. They of x, absolute value of x minus h plus k. So the first thing to know is that the a. Okay, what that a is that is the average rate of change. Okay, that's kind of like our slope. And do you see when it was negative how I went down 1 over 1, down 1 over 1, down 1, left 1, down 1 over 1. So that would be the negative 1 over 1 type deal. So that's our average rate of change. Now, if we have a positive a, what that means is that our graph opens up. See, in our first graph, it opened up. And there is no reflection on the x-axis. If we have a negative a, that means it opens down and that there is a reflection on the x-axis. Okay, now one more thing, hopefully won't be too rough for you. On our parent function, do you see that point right there? That's our vertex. That's the bottom of the graph. That is the min, or the minimum. So when it opens up, we could say that there is the vertex is the minimum. Okay, I'm going to write that in a different color. The vertex is the minimum value. Now, when it opens down, the vertex is the max value. It's the high as it gets. So the vertex is the maximum value. Okay. Now, last thing that we need to know is the vertex. The vertex is h comma k. So what we need to do is we need to take the opposite of h, and then the k stays the same. Okay, now if you think about it, our vertex right here was -1 comma 2. So I took the opposite of 1 to get -1, and then the 2 stayed the same. And I know it's a lot to take in the first like 9 minutes. It's like, whoa, don't worry. We're going to go through all of this. So the first thing that we need to do, we're going to graph each function and identify any transformations compared to its parent function. So we have the absolute value of x minus 5 minus 4. So the first thing, is there a reflection? Well, if I'm looking for a reflection, I look out front. Since there is no negative, there is no reflection. Boom, done. So I know that it's going to be opening up. My vertex, where I start, I take the opposite of that number. So we'll put this in a different color so it's easier to see. I take the opposite of the -5, which is a +5. And this number stays the same. So my vertex is at 5, -4. So I go to 5, -4, boom, there's my vertex. And since it opens up, I just go up 1 over 1, up 1 over 1 in both directions. And that's how we get our graph. And then it would just continue with that pattern for the entire time. Okay? Now, do we have a minimum value or a maximum value? Well, right there, I see the min. That's as low as it gets. Okay? So we would say that it has a minimum value. Now, compared to our parent function, okay, I can come over here and I can clear out that function and type it in real quick, but we should be able to see that x minus 5 and it was minus 4. Okay, there's our parent function. Now we had to go see how there's a horizontal shift. It went over 5 and a vertical shift down 4. Okay, so we would say that there is a horizontal shift, which was right 5. There was a vertical shift where we went down 4 and there was no reflection, which we don't need to say. Okay. All right, next one. So the first thing we look at, is there a reflection? And guess what? Yeah, there's a reflection. There's a negative. So I know that this is going to be going down. So to get the vertex, I take the opposite and I take the same. Well, there's nothing out there. It's same plus 0. So my vertex would be -3, comma 0. So at -3, 0 is where I would graph it. And now since it's there's a reflection, I would go down 1 over 1. Whereas before, sorry, I didn't write it down here, we went up 1 over 1 in both directions. Okay? So I'm going down 1 over 1, down 1 over 1. And I'm doing that in both directions to make my V. And then I'm using my ruler, my straight edge, to graph. Okay, so is the vertex a max or a min? Well, just look, since it's going down, I see the max point. So the vertex is a, sorry, wrong pen, max value. So now we have to explain the transformation. Well, there was a reflection because it's going the opposite direction. And then there was a horizontal shift. And we went left 3. And if you want to, you could say no vertical shift. Okay. And of course, my graphs would disappear. Hold on. Okay, there we go. So let's go through these. For number 3, is there a reflection? Yeah, so I know that this is going to be going down. So since I know it's going down, I can already say, well, if it's going down, that means I'm going to have a max, and I'll prove it to you in just a second. Now, the vertex, remember we take the opposite, and then we take the same. So the opposite of -1 is +1, and then the 7 stays the same. So since it's going down, the reflection, I know it's going to be down 1 over 1. That's going to be my rate of change. So we start at 1, 7. I know it's reflected, so then I'm going down 1 over 1, down 1 over 1, and I do that in both directions. And it's just following the pattern, guys. Okay? So I'm going to go ahead and use my straight edge. And after we're done with this, we need to describe the transformation. Okay? So we have a lot to talk about because one, there was a reflection on the x-axis. There was a horizontal shift, and we went to the right one. Are you guys starting to make the connections with these yet? So I went right 1, that was my horizontal shift, okay? And then there was a vertical shift. I went up 7. And the reason I went up 7 was because of that number. And if you look, 0, there was no vertical shift. -3, I went left 3. I went right 5 because I had a +5. -4, we went down 4. Okay? That's why we're doing all of that stuff. Okay? So for number 4, I just want you to try it on your own. Okay? And then we'll go over it. Make sure to do it in pencil. Go ahead and pause the video, and good luck. Okay, and there we go. So I know it's a minimum because we're going up, so that's my minimum value. My vertical shift was left 1, and then my horizontal shift, I'm sorry, my vertical shift was down 6, the horizontal shift was left 1, and then since there's no reflection, we just go up 1 over 1. Now, for these, once again, I'm missing half of them. So 5 through 6 we'll do together, and then 8 through 10 I want you to do on your own. Okay, so let's just see how quick we should be able to do these. Now, is there a reflection? No. Okay, so if there's no reflection, I know that it's going up. Now, my vertex, I take the opposite, and this stays the same. So my vertex would be -2, -5. Since it's going up, okay, I have a minimum value. And then I'll match my colors right here. Our horizontal shift, we would go left 2, and then our vertical shift, we would go down 5. Okay, and once again, that's why. Okay, so for our next one, number 6, is there a reflection? Yes, there's a reflection. Now I know that my graph's going to be going down. It's opens down, so I know that there's going to be a max value. Okay, our vertex opposite, so it's going to be 4, and this stays the same, 7. So my vertex is the point 4, 7. Okay, so our transformations, there's a horizontal shift. This graph would go to the right 4, and there's a vertical shift going up 7, okay? It's a positive 4, so I went right 4. It's a positive 7, so I went up 7. Okay? Last one together. Is there a reflection? Yes. Our graph is going down, and if it's going down, I get to see the max value. Now, I would take the opposite of what's inside, but there's nothing inside, so that's a 0. This is the same. So that is the point. Our vertex would be 0, 6. Well, if my vertex is 0, 6, there is no horizontal shift. And then our vertical shift would be up 6. And our graph would go up 6 because of the 6 right there. Okay, well, let me switch over to the notes real quick because you guys are going to do 8, 9, and 10. Okay, pause that video. Good luck. Okay, and there you go. So for 8, there's a reflection, which means it's going down. If it's going down, I can see the vertex is the max. It's the highest point. Our vertex is negative 8, 11. And that means negative 8 means a horizontal shift of 8 to the left and a vertical shift of positive 11 going up. All right, number 9, there's no reflection, so it's a min. The vertex is negative 9, 0. Negative 9 means horizontal shift left 9, and the 0 means no vertical shift. And then number 10, you can see all my work. All right. Well, guys, that's the end for Algebra 2, Unit 3.4 Notes, Day 1. If you have any questions, please come see Ms. Carranza or myself. We would love to help you out. Otherwise, this is Mr. Grice signing off. Thanks for watching.